2 of our unit here at Green Acres Middle School. I'm Mr. Gallant.
And I'm Coach Parrish.
And we're doing Earth's Place in the Universe, Unit COVID-19. Now, in Lesson 1, we made some observations based off of that video that we watched. We saw that the sun, the moon, the clouds, and the stars are moving, but the Earth wasn't moving.
Correct.
We saw that the sun and the moon were moving at the same speeds, but the stars are moving slower and the clouds are moving faster. We noticed that the tree was some of the biggest things that we saw. The sun and the moon were about the same size, and that the stars were really, really small. And that the brightness, the sun and the moon, seemed to be about the exact same brightness, while the stars were very, very, very light.
That worked. So what questions do we have based on these observations? Our first question was, are the sun and the moon the same size? Our second question, how fast or slow is everything actually moving? And our third question is, why are the moon and the sun so bright?
Now, we made a model yesterday. We knew that model was wrong.
Yeah,
it can't be right. And that's what we're going to do today. We're going to learn a little bit more and be able to improve our model. Now, in order to learn a little bit more, we're going to start Lesson 2, and our main question here is, how is the Earth moving? Because we know it can't be sitting still. Something has to be going on. So we're going to do an experiment. What we're going to do is we're going to move the camera. We're going to move the camera towards us, away from us. We're going to move the camera in a circle. We're going to move the camera up, move the camera down, and left and right. And what I want you, the watcher of this video, to do is pay attention to what you see of us and what you can see of this star that's going to be behind us.
This is a star. Just FYI. It's a star.
That's a star. So, let's go ahead and pause the video, and let's get ready for our direction. So we made some observations when we were doing the different movements of the camera.
Correct.
We went up and down, and what we noticed that the star and the teachers did not disappear. They pretty much stayed the same size the whole time. We went left and right, and the star and teachers did not really disappear, but they came in and out of view and stayed the same size. But what it really got interesting is when the camera moved towards us. We said the star and the teacher got bigger, and the teachers disappeared from view the closer it got. But then the camera moved away. When the camera moved away, the teachers came back into view, and then the star and the teachers became smaller and smaller. But my favorite part was when we started to spin the camera. What we started seeing was that the star and teachers disappeared from view, and then reappeared, and then disappeared, and reappeared. And that reminds me of what we were seeing in our initial video from Lesson 1. So let's go back and watch that video and see if you can see those things too. Okay, so we just watched the video again,
Correct.
and we have some observations, and we're going to think about our initial video going to our anchoring phenomenon video. So what did you
Yes.
notice, Coach Parrish?
Well, things that I noticed and that we noticed too in the video was that in this image we see that the sun, the moon, the stars are all moving from the left side to the right side. And they all start moving from a downward position to an upward position.
Okay. So it's kind of like these two things at the same time. It's moving up or down and up, but it's also moving left and right at the same time.
Yes, at an angle. They all start about right here and they all end up about right over here.
Okay.
Okay? And then we also noticed that when it comes to the sun, when it came from down here and it got about right up here, we noticed that it got a little brighter. And the same with the moon. When it came from down here and got about the trees, it got brighter. Which means if things seem to be brighter, they got to be getting kind of closer. Which means at some point they were once a little further away and got a little bit closer towards us.
So we're seeing these two at the exact same time. We're seeing these two at the exact same time.
Correct.
Almost like we're seeing all four of these happening in that video.
Yes.
Now, what did you notice about the rotation and the circling?
Now, I noticed about the rotation and the circling is that in our video that we did, we see that things are moving in and out of view with the camera spinning, but in the phenomenon video, the camera was in a fixed view. So I think we should do one more video with that variable of spinning, but with the camera at a fixed view. So let's go ahead and do that experiment.
So we have our star.
Correct.
This is our star.
Yes.
And we have our two teachers, but instead of the camera spinning, the camera's going to kind of stay the same direction and go around us.
Correct. Just like in the phenomenon video. It had that fixed spot that didn't change.
That works.
So let's go ahead and try that.
Let's see how this looks.
So in that last video with the experiment, our variable was we had to keep the camera position fixed. And which you saw, we did that. But as you noticed, throughout that video, things came in and out of view. They got closer, and they got bigger, or they got smaller, and a little further away.
So we saw all four of these things at the exact same time, kind of like what we saw in our anchoring video.
We kind of did. We definitely saw these two. The up and down, we'll get to that one later. And we'll fix this one too. But when that happens, when we moved around, we had to rotate around something or move around something. And that's what's called a revolution, or like an orbit. A revolution is when one object moves around another one.
Okay, well, you know what, Coach Parrish? I'm more of a visual learner. I want to see it on the board. Why don't we go to your room and let's make a new model, because we know our first model was wrong.
Yeah.
Let's make a new model based off what we now know.
Sounds great.
Okay, here we go. Okay, so now we're in Coach Parrish's room.
Yep.
And we know that the model we did in lesson 1 was completely wrong.
Yes, absolutely wrong.
And now we have some new evidence, we have some new observations. So let's think about our new evidence and our new observations so that we can make a new model.
Okay.
Now, part of our new observation, our new evidence, was that rotation video. The camera was spinning around, and Mr. Gallant and Coach Parrish were completely fixed. They did not move. And what we saw is that things moved in and out of view, which is what we saw in the anchoring phenomenon video.
Correct.
What else did we do, Coach Parrish?
Well, what we did when we ran the last video was that we ran the variable that the camera view was fixed. So we have what's called a revolution, to where the Earth moved around Mr. Gallant, which was the sun, Miss Austin, that was a star, and me, that was the moon. And we saw things move in and out of view, but they also got bigger, smaller, because they got closer and they got further away. And so moved in and out of view, things got bigger and smaller, but we saw multiple things at the same time. We would see the star and the moon in the same view, and we'd also see the moon and the sun in the same view.
Now, I've been outside a lot of times and seen the moon and the sun at the same time.
So have I.
So this model makes a lot more sense right here.
It does.
So what about our anchoring phenomenon video? What's the problem with that?
Well, the anchoring phenomenon video, things did move in and out of view. We did have the fixed position of the camera view. Things did seem to get bigger, smaller, and move away and towards, but we didn't see as many multiple things at the same time. We did see star and moon at the same time, but we did not see moon and sun at the same time, which we know we can see.
So what we know is our first initial model was wrong. Our initial understanding of the anchoring phenomenon video was wrong.
Correct.
So why don't we redraw our model now, and actually based off our new observations and our new evidence. So if we're talking about Earth, we now know that Earth is spinning on a rotation.
Yes.
That Earth is spinning on a rotation, right?
Yes, but there's a problem with this one.
Okay.
Because in the phenomenon video, everything moved from left to right. And in this video with the revolution, we had things go left to right, but when we got on this end, things started moving right to left.
So we're not spinning clockwise, we would have to be spinning.
Counterclockwise.
Okay, that makes sense. So we have our Earth, and we are spinning counterclockwise.
Correct.
So that gets our rotation in. Now our revolution. So we know since the Earth is moving counterclockwise, that means that the Earth is also doing a revolution counterclockwise. But the
Yes.
question is, what are we doing a revolution around? Is it the moon? Is it the stars? Is it the sun? That's where I'm confused. So what are we doing a revolution around?
Well, we'd have to put the sun here
Why?
because we have seasons.
Seasons. That is a really good point. We have seasons. So if we put the sun right there, that would actually help us give us our seasons as we move around the sun. Because the sun gives off heat. The moon doesn't give off heat.
No.
Stars really don't give us heat. So in order to get our seasons, we got to have the sun as we revolute around it.
Yes.
Brilliant. Okay, so now we have our new model, the Earth spinning counterclockwise.
Correct.
The Earth going around the sun counterclockwise. Now let's go back to my classroom. Let's review what we learned in lesson 2.
Fair enough.
Okay, here we go. Nope. This way. This way. This way.
Ah!
This way. This way. This way. Maybe later. Okay, this isn't right.
This really isn't right.
Oh, okay, made it. So first of all, we have our lesson question, and then from the beginning of the lesson, and our lesson question was, how is the Earth moving? Now, we figured a lot out, we have a lot of evidence, so Coach Parrish, why don't you walk us through that?
We do. What did we figure out? Well, the Earth spins. The Earth moves around the sun in a circular-ish pattern. And the movement, it continues, and it spins towards the east. That means Earth spins towards the east, or counterclockwise to the left, so everything moves from left to right. And then our evidence is, when you move in a circle, your reference points seem to disappear for a while. And then as you move, some objects change size and reappear. And everything moves from left to right.
Wonderful. So we have all of our evidence compiled here. Now what we want you to do is there's going to be a student reading that's going to be attached with this lesson. And what it's going to be called is, what are constellations used for? It's a really cool reading about how we base a lot of our science information off constellations. Now there's a couple of things I want you to be thinking about when you're reading it. First, could something else be changing as the Earth spins in a circle around the sun? And could the seasons be related to the constellations? And how can we investigate these new questions? So be thinking about these 3 questions, and that's the end of lesson 2. So I guess we'll see you in lesson 3.